We are going to see in detail about constraint satisfaction problem. So for that I'm going to take an example. This can be solved using the script arithmetic algorithm. So I'm going to take an example which is ur plus u is equal to hot. We are going to prove that ur plus u is equal to hot. That is the thing that we are going to do. So for this thing I'm going to follow the steps like CSP, that is constraint satisfaction problem, will have a rule, that is it will be having three things, which is set of variables, set of domain, and set of constraint. In our case the variable is like nothing but y, o, u, r, and again you can see y, o, u is repeated, so we need not put again. And another thing is hot, h, e, a, and r is repeating. You can see that r is found in ur, so I am ignoring the tar and I am putting the t. So a set of variables u comma o comma r, u comma r comma h comma e comma a comma t, in this way. So these are set of variables. Next comes the set of domain. Set of domain is like it has having some rules, that is y and h should have a value which is like they're ranging from 1 to 9. Why? Because that is the starting position of a sentence, that I mean words. Your, in case of your, y is a starting position. In case of you, y is a starting position. In in hot, h is a starting position. So these variables can possess a value, say for example 1 to 9. So it should be like having a value between 1 to 9. In other cases, in other set of variables, it can hold a value from 0 to 9. That is a scenario. And we have a set of constraint, that is the rule is like we cannot give the same value to another variable. Say for example y is given a value of 9, the same value 9 cannot be given to e. So that is a rule that we have to follow. So if in our case h should have a value, say 1, so that is the greatest possible value, because if you add anything with 9 you will be getting 18. So I told you already 9 is the maximum value. So 9 plus 9, 18 will be there. So y will be taking a value of 9, for example, e will be taking in value of 18, for example. So a should have, I mean h should have a value 1. That is the thing, that is highest value h can have. So I can take the value of h as 1, and so it proves that y should take a value 9. So that is the thing that we are going to do now. I will do I will explain step by step. We can see so I have I have introduced one thing like c1, c2, c3, c4, which is going to be carry. Whenever we are adding two numbers, carry is like a basic thing that we follow from our to second or first standard. When we are adding r plus u is equal to t, suppose t value is 10, what will happen? T will be taken as 0 and 1 will be forwarded as carry. So c4 will have a 1. So in that way c1, c2, c3, c4 are carries of this addition. So I have simplified our problem into this. Now initially y should have a value of 9. I told you so because y should have a maximum value and it should have a carry, because y and e cannot be same. So if say y is 9, e cannot be 9. That is a rule that we saw. Why y is taking value of 9 is like height should be 1. That is a domain value. So height should not, h cannot be 0. So height should have a value greater than 0. So h value should be 1. In that case y value should be 9, because as I told you, it will be getting a carry, because y and e cannot be the same. So if I assign y value as 9, if there is no carry, it means that e will also become 9, so which is wrong to our constraint. So if y value is 9, e value will be 0 and there will be a carry. That is what I put here. And 1 plus 9 will become 10, so e becomes 0 and the carry of e is going into the c1, and I'm putting h as 1. So it is proven that y is 9 and e is equal to 0 and h is equal to 1. I hope you understand this. I've introduced y value as 9 wherever I found this y. I hope you understand this. Okay, next is I have introduced the list in the above diagrams. You can see 0 to 9 there. I was shaded like with black, which if the value is taken, I have shaded with black. That is the thing. So y is equal to 9 and e is equal to 0 and h is equal to 1. That I have shaded with black. Now we can check the next thing that you are going to find is like 0, that is o plus 9 is equal to a. That is the thing that we are going to find now. So I am going to discuss the possibility 1 and 2. you know that o plus 9, that is o plus y, that is we have introduced 9 for y, so it is o plus 9 is equal to 10. Why? Because it should have a carry that we have discussed in the previous slide. That is, there should be the c2 value should be 1 that we have discussed. So o plus 9 should be 10 and a will be additional value there. So o plus 9 is equal to 10 plus a. That is the thing that we are going to solve here. And then if you take in the next step, that is o is equal to a plus, I am bringing the 9 to the other side, which is a plus 10 minus 9, which is going to be like plus 1. So o minus o is equal to a plus 1. Then I am bringing the a here, so o minus a is equal to 1. This is a possibility 1 I am getting here. And the next possibility is not possible, because that says that 1 plus 0 plus 9 is equal to 10 plus a. What is the one? The c3. If suppose c3 value is 1, in the possibility 1 I am taking c3 value as 0. In possibility 2 I am telling that if c3 value is 1, what happens is 1 plus o plus 9 is equal to 10 plus a. That is the thing. O equal to a plus 10 minus 10, because I am bringing this 10 to the next side. So 10 and 10 will be getting cancelled, which implies that o is equal to a, which is not possible, because our constraint is that if I assigned a value to o, I cannot give the same value to a. That is the thing. So possibility 1 alone will be possible. So I have an what is it, formula that o minus a is equal to 1. It I can you can see in the left hand side yellow color, which means that o and a should be greater than 1. Why? You can see in the black color above, which tells that 0 and 1 are taken. So I cannot have a value, like I cannot pass 0 and 1 to o and a. That is the thing. And I have another rule, that is o minus a is equal to 1, which means that suppose say o value I am assigning as 2, means a value should be 1, which is not possible again. So we'll see step by step. And again c3 should be 0, because we proven in the possibility that c3 value cannot be 1. I hope you understand this. We'll go to the next slide. So next slide is I'm assigning a value 2 to o. As I told you already, here what happens is o is assigned a value 2. You can check if 2 plus 9, that is I am assigning 2 to o. 2 plus 9 is equal to 10 plus a, which happens is like 11 is equal to 10 plus a. Now a value will be 1, which is not possible. Why it is not possible? Because 1 is already been taken. I have marked it as a black color above. So it is not possible. So I am going to the next thing, that is o is equal to 2 is not possible. Now I am going to assign o value as 3. What will happen is, if o is 3, 3 plus 9 is equal to 10 plus a, which means 12 is equal to 10 plus a. So I will get a is equal to 2. And I am going to check with the algorithm that o and a is greater than 1. Yes, it is greater than 1, because 2 and 3 are greater than 1. Then again o minus a is equal to 1. Yes, 3 minus 2 is equal to 1. So I can assign a value o is equal to 3 and a is equal to 2. And another thing to be noted is 2 and 3 are in free state. So I can assign the value 2 and 3 to o and a. Okay, so here I have assigned, see here I have assigned 3 and 2 to o and a. And 3 plus 9 is equal to 12. So I will be putting a value as 2 and the carry will be there 1. So which is correct to our knowledge. Now I am going to check the value for u and o. So u plus o is equal to r. Since there is no carry, I cannot put 10 plus r. So that is the principle here. So u plus o is equal to r. So r should be less than 10, because there will be no carry. That is the principle here. And u should be less than 7. Why it should be less than 7? Because o value is 3. So if suppose I have given 7, mean what will happen? U plus o, it will become 10. So I will send a carry, which is not possible. So it should be less than 7 if z4 is 0. Say what is that? It is mentioning that c4 value should be 0. In that case, I can use u value up to 6. So 6 plus 3, I will get 9 only. So that is the thing that I am getting. I'm assigning here. If c4 is 0, mean I can give a value u as less than 7. Since okay, that is what I mentioned here. Then another case is, if c4 value is 1, I can take u value as less than 6, which means that I can give a value less than 6 in the case of there is a carry, which means I can give up to 5 plus 3 plus 1. And again, and we'll be in discussion, like 9 should not be possible because it will be assigned for or if r value is given a 9, it will be given for y, so that is not possible. So what I'm going to do is I'm going to give a value, the next value, that is, you can see in the above diagram, 0 1 2 3 is assigned. The next free value is 4, so I can assign the 4 value to say u. So u is equal to 4. What happens is 4 plus 3 is equal to r, so I am getting r value as 7. So this is the thing that I have derived now. So here I have derived the u value as 4 and r value as 7. Why I am assigning the 4? Because 0 1 2 3 has been taken. The next possible value that I can assign to u is 4. So that is why I am assigning a value 4, and also I am following this rule, u should be less than 7 or u should be less than 6. In that way I am following this rule, and I am assigning a value from the starting value, which is like 4 is free, so I am assigning u as 4. Okay, so I am getting a value r as 7. So when I am assigning u as 4, what happens is I have marked in yellow color, you can follow that. I have assigned u as 4, and I have a value which is o as 3, which happens like 4 plus 3 is equal to 7. It will come initially as 7, but what happens is in the next case, you can see in the left hand side of the diagram, u value, suppose I am giving as 4, o value was 3, it will return 7. That is okay. Now when I am assigning r as 7, what will happen? R value will be 7 and u value is 4. I am substituting that. So 7 plus 4 is 11. When I am assigning 11 here, the carry 4 will be having a value like 1. So u4, that is 1 plus 4 plus, you can see in the right hand side, 1 plus 4 plus 3 will become 8. So there is some contradiction. So see, r value is 8 in the u plus o, and r value is 7 in the r plus u. So there is some contradiction. So I cannot give a value 4, and also I cannot give a value greater than 4, which will be a contradiction. Why? Because it will send a carry to the next thing. So I cannot assign a value greater than 4 here. So that is the thing that we have to follow here. So what I should do here is I have to backtrack. So why I am backtracking? Because you can see here I assigned a value u as 4, which is the smallest value. For that smallest value I am getting a value, say 8 here. That is r value is 8. Suppose, say, if I am assigning the next value 5, what happens? 5 plus 3 will become 8. It will go into the next prediction, that is 8 plus 4 will become 12. So what will happen? 12 and the carry will be 1. So what will happen? The r value will become 9, which is going to be wrong because 9 has been already taken. I cannot give a value greater than 5, as I told you already in the previous slide. You can see that I cannot give a value greater than 9. Greater than 5, because I am following this rule here. I will get a carry and I cannot give a value greater than 5, because u should be less than 6 if it is getting a carry. So based on this rule, I cannot give value 4, 5. So if I cannot give 4, what does that mean is I cannot give a value greater than 4. That is the thing that I have explained now. So what I'm going to do is I'm going to backtrack. So where I'm going to backtrack? So this is a step I should backtrack. I should change the value of o so that I will get different value for u. So that is where I going to change. So this is the thing that we have done previously. So I get when I assigned a value for o, I get a value for a. So I'm substituting those and I'm getting a different value for u, which lead to a non-solvable issue. So I'm going to backtrack this algorithm. I'm going to a step to the initial step where we are here in this position. Now already we assigned o as 3. So next what I'm going to do is, so this is the previous step that we have assigned. Nothing to see about this description here. So I'm going to go to the next slide. So this is where we left out. Now I'm going to give a value 4. Already we decided that when we give the value o as 3, what happens is like we are not able to solve the issue. So I'm going to take the next value, which is o is 4. So if o is 4, what happens? O minus a should be 1, which means that 4 minus a, which is going to be like 1, that is a value will be 3. That is what we solved here. So this will be pretty much clear because we are repeating this is steps. So if O value is 4, A value should be 3. So what is that left out is you can see in the left hand, y has taken the value of 9, O is assigned the value 4, and A will be taken as 3. I am substituting those values here. So you can see here, instead of O I have put 4 there. So 4 plus 9 it becomes 3, 13. So 1 carry is there. So C3 will be 0. So that is the thing, because if I'm getting A value was 3, 3 should be also 0. Okay, now this is a step we are changing, like we are backtracking. See, in the above diagram, the 2 is left out and 5, 6, 7, 8 are left out. Now we are going to assign values for, we are going to find the value for U, R and T. I hope you understand up to this. Now suppose I have the step that U plus O is equal to R. So then, like earlier we tested with 4, because we in the previous steps we checked, we put U as 4 and it failed, and we also predicted that U should be less than 4. So I am taking the value less than 4, where we can find that only 2 is left out. So I am assigning a value as 2 here. U value I am assigning 2, because earlier we checked with 4 and we found a wrong solution, and we predicted that U value should be less than 4. So if you check the above Q, only 2 is left out, so I am assigning the value 2 to U. Okay, so I'm changing the value of U to 2. You can find that. So 2 plus 4, you'll be getting 6. We'll go to the next step. Nothing to see here. So only thing that we have introduced is U value. I'm putting U as I have substituted U as 2 here. Okay, so then here what happened is I found the value of R here. See, U plus 4, that is 2 plus 4 is equal to 6. That is what we derived here. So R value is found by substituting the U value. So I'm going to substitute R wherever R is there. I'm going to change the value to 6. So I'm getting the value T as 8. So it is, you can check in the left, there is no repetition of values. There is no repetition of values. We are very much clear about this, the value that we found. So we also satisfied the constraint here. So this is our algorithm, and this is our procedure. So this is an initial problem, and for this initial problem we are assigning these values, and it solved our thing. I hope you understand. So if there is any doubt, just put me. And you can see that the 6 plus 2 is equal to 8, there will be no carry, so C4 has become 0. Again 2 plus 4 is equal to 6, there will be no carry, so C3 is become 0. So 4 plus 9 is equal to 13, so 3, so there will be carry for C2. So 1 plus 9 is equal to 0, so there will be carry, so 1 is became then. I think it is solved. Thank you.